In number 28 here, they've given you two functions, f of x and g of x. They want you to calculate both of the composite functions, f comp g and then g comp f, and determine the domains of each one. So let's get started on the first one right here, f composition g of x. Most people kind of prefer to write this as f of g of x, which means we're going to rewrite the f in the outer set of parentheses, and the g of x on the inside is going to get replaced here by x to the negative fourth. Now, what we're going to do with that x to the negative fourth is put it right in there for the x. So this is kind of weird. This becomes 1 over x to the negative fourth, and it never makes any sense to have a negative exponent in the denominator, so we would move that up and make that x to the fourth. So that's the answer to the first part of this problem. That is the first composition, f comp g of x. And they also want you to determine the domain of that function, and I'll bet this is where the question that was asked here actually came from. Because as we look at x to the fourth right here, we can see pretty simply that that's a polynomial function, and that would suggest, therefore, that the domain of this was going to be all real numbers, which it is for every polynomial. But I'll bet, and I'm sorry I didn't look this up, the answer for 28 is actually not that for the domain. Because what you actually need to do here is focus on the individual steps you took to get to this point. The first thing you did is you would have plugged an x value here into the g of x function, which is right here. And of course, another way of writing that would have been 1 over x to the fourth. And what can we put in for x there and get a real result? Well, positive and negative numbers would be fine, but you can't put a 0 in there for g of x and get a real result. So since you can't put a 0 in here and get a result, there would be no result to therefore put into f and end up with this value right here. So what we have to say then is that that's kind of a limiting domain right there, and our domain for f comp g would be all x that are not equal to 0. So I'm kind of stealing the domain from this function, which is of course also the domain of this function. So that's what I would have said for that domain right there, and I probably should have labeled that a little bit better right there, but there you go. And guys, I'm not looking for anything real fancy right here in terms of interval notation. I'll be okay accepting that if you write that x can't equal 0, that implies that x could equal every other real number. Okay, let's take a look at the second part of this problem now, where we're now going to do g comp f of x. So again, I rewrite, I'll write it this way, g of f of x, and I will rewrite the outer function, g, the empty set of parentheses, and the f of x now is going to get replaced by 1 over x. You could write it as 1 over x. Might be easier to write it as x to the negative first, because now you're about to take this value, x to the negative first, and put it in here for g of x. So x to the negative first to the negative fourth, let me write that out just so you can see it, x to the negative first raised to the negative fourth power here is going to get us then, we're multiplying exponents right here, we're going to end up then with x to the fourth power. Power of a power, we multiply our exponents right there. Yeah, that looks correct to me. So I'm a little surprised, I wasn't expecting this right here, that we ended up with the exact same expression now for both f of x, f comp g, but also g comp f of x. Usually when that happens, that means that your functions are inverses, but for that to happen, you have to end up with just plain x here for these compositions, not x to the fourth like we have right now. So that's an interesting counterexample to that concept. Okay, so the domain of this one, again, you might be tempted to look at it and say that the answer is all real numbers, but you've got to realize that your first step here was to evaluate f of x. And what can you not put into f of x to get a real result? Once again, x cannot equal 0. So that's going to be our domain for this second composition here as well. So that looks like the answers to the two parts there to problem number 28. So remember, you can't just look at the final result to determine your domain. You kind of have to look at the individual functions that you used along the way in order to get there.